Good morning, students. Yesterday's class relate to problems. These are the yesterday's class we discussed about Coase-Lewis theory, Lewis dot structure, Rawls limitations of octet rules. Okay. Now the first question once observed here, the covalency of aluminium in a AlClH2O taken 5 plus 2 is. So, and options 3, 5, 1, 6. Once observed, the given compound is example for a complex compound. Already you listened in a coordination chemistry topic, and based on that concept, in that one concept once observed here, Verner's theory concept. Verner's theory concept, according to Verner's theory, we have two types of valencies, primary valency and secondary valency. You know already. Complex having two types of valencies, primary valency and secondary valency. Primary valency 1 degree, secondary valency 2 degree. In that one, primary valency is equal to oxidation number and secondary valency is equal to coordination number. So, in this one, in this given complex, aluminium is completely bonded with two types. One is chlorine, another one is 5 molecules of H2O. So here total 6 molecules and 1 atoms. 6 molecules and 6 molecules combined with aluminium, and the coordination number is 6. Now coordination number 6, that one coordination and secondary valency is also equal to covalent bond. Covalent bond. So in yesterday's class already said covalency nothing but covalent bond representation, and here coordination number equal to covalent bond. Now coordination number 6, then covalent bonds are 6, then covalency is 6. In this complex, aluminium covalency is 6. Then same relative problem you can practice. Then I am discussing the third one. Among the following, the electron deficient compounds, and here first option is CCl4, PCl5, SiF4, BCl3. Okay, and once observed question here, electron deficient compound is which one? So in the yesterday's class I said limitations of octet rule. First limitation is here. Then once observed in this one central atom is, first molecule central atom is carbon, and carbon is totally bonded with 4 chlorine atoms. That means the covalency of carbon is 4. So that one is not example for electron deficient compound. And here PCl5 is example for covalent compound, already you know. And central atom phosphorus is bonded with 5 chlorine atoms. Then that means covalency is 5. So 5 bonds present around the phosphorus. Then 5 into 10 electrons. That is superoctet company. Here it is not a electron deficient compound. Similarly here SiF4, silicon covalency is 4. That means 4 means around silicon 4 electrons are present. Then it is also not electron deficient compound. Once observed the fourth one, boron belongs to third group element, and covalency is here 3. And once observed around the boron 3 bonds are exist and then 3 bonds means 6 electrons, so less than 8 electrons are present. Then this boron trichloride is example for electron deficient compound. Okay. Then next one more question. Covalency for central atom is maximum in following compounds. So the 4 options is given better. In that one, first option is BF3. In that one, covalency maximum they are asking. So here number of bonds around the boron is 3. Then covalency is 3. And once observed in this one, sulfur, I am drawing here diagram. Already you know BF3 diagram. Now this is what 3 bonds. So then their covalency is 3 and sulfur SO2 Cl2. So ionic chloride. In that one, once observed around the sulfur atom, how many covalent bonds? 6 covalent bonds. Then that covalence is 6 here. And next POCl3. Here diagram is now around the phosphorus how many bonds are present? 5. Then covalence is 5 in this molecule. BeCl3 already you know covalence of that one beryllium trichloride is 2. And here which one is answer? Correct one is SO2Cl2. Then next fifth question is octet rule is not valid for the following molecule. That means what? Which one is not obeying the octet rule? What is octet rule? Yesterday I said maximum 8 electrons present around the central atom for its stability. So in this molecules CO2 molecule around the carbon atom we have 8 electrons, and then it is obeying the octet rule. In nitrogen already you know now once observed here around each nitrogen atom 8 electrons present, then it is also obeying the octet rule. And O2 diagram also you know. Now each oxygen atom having 8 electrons, then it is also obeying the octet rule. And here only I draw BF3. Now once observed in this one, here boron central atom, boron is combined is around the boron 6 electrons are present, then it is not valid. So our answer is this one is not obeying the octet rule. Then this is our answer. Answer is D. So this is extra days related to problems. Okay, students. Next topic is classification of chemical bonds. Here, chemical bonds are two types. One is interatomic chemical bond. Another one is intermolecular chemical bond. So, what is meant by interatomic chemical bond? The chemical bond formed between the two atoms, that is called interatomic chemical bond. And intermolecular chemical bond means the chemical bond exists or formed between the two molecules. Then they are called intermolecular chemical bond. So here interatomic chemical bonds again three types. First one is ionic bond. Second one is covalent bond. Third one is metallic bond. Here already you know covalent bond having one exception bond, that one is a coordinate covalent bond. Simply it is called day-2 bond. So including day-2 bond totally 4 types, but I classified into 3 types only. First one is ionic bond, second one covalent bond, third one is metallic bond. And here these bonds are strong bonds. That means the attraction forces is very strong. Okay. Then here intermolecular chemical bonds are two types. First one is hydrogen bond. Second one is van der Waals forces. So here this one is, these are two types. Okay, so this is our chemical bonding chapter ready. Then in this one we are discussing first ionic bond. And what is it here? Interatomic chemical bonds are strong bond. That means intermolecular chemical bonds are weak bonds. That means the attraction forces is weak. So this one is a classification of chemical bonds. Okay. Next topic is ionic bond. So ionic bond also called, yesterday I said, what is electronegativity electrovalent bond. Ionic bond also called electrovalent bond, that is EB, electrovalent bond. Okay. Now, generally ionic bond is formed in between the two oppositely charged ions, that is cation and anions. So, what is actual definition? What is actual definition? Here, in between two opposite, already what I said here, ionic bond is formed in generally two oppositely charged ions. The two oppositely charged ions are holes by strong electrostatic force of attraction. So that's why the two oppositely charged ions are formed one type of bond. That bond is called ionic bond. Okay, now actually what is definition? The strong electrostatic force of attraction. The strong electrostatic force of attraction which holds the two oppositely charged ions which are formed due to the transfer of electrons from one atom to the another atom, that is called ionic bond definition. మీకు అందరికీ కూడా నోట్స్ లో ఉంటుంది ionic bond definition. And here main points in this one. Ionic bond, especially ionic bond is formed between the metals and non-metals. Metals and non-metals. So, metals example, first A group elements, second A group elements, and non-metals best example is 16th group, that is 6th A group elements, and 17th group elements, 7th A group elements. So especially ionic bond exists between these two groups. First A, second A group elements are best examples for metals, and 16th and 17th group elements best example for non-metals. And here second point is formation of ionic bond is a redox process. Redox process. I think you know redox process. So what is in this one? Redox. That means what? In that one, RED indicates a reduction, and OX indicates a oxidation. Oxidation. That means during the formation of ionic bond, one atom undergoes reduction, another atom undergoes oxidation. That's why the formation of ionic bond is called redox process. We will discuss later about that formation of ionic bond. Next one is maximum electrovalence in the ionic bond is 3. That means electrovalence means what I said yesterday, the number of electrons transferred per atom. So here in the ionic bond formation, maximum 3 electrons are transferred. Okay, now I am taking one example. Formation of MgO. Formation of MgO. Before that, one point remember better. In the ionic bond formation involves First one is formation of cation, second one is formation of anion, and the third one is electrostatic force of attraction present between the oppositely charged. So three steps are involved in the ionic bond formation. Okay, first one is formation of cation and anion and electrostatic force of attraction between oppositely charged ions. So here our example is formation of MgO. So in that one, magnesium. Magnesium belongs to which group element? Second A group elements. So here magnesium is in a gaseous state. It is converted into magnesium ion by loss of 2 electrons. By loss of 2 electrons. So here in this process, what happens? Electrons are lost. That means loss of electrons is called oxidation. Loss of electrons is called oxidation. Oxidation is equal to O. Here why it is lost? Once observed electronic configuration of magnesium atom 2 1. That is what 1s2, 2s2, 2p6, 3s2, 3s2, 3s2. And whenever it is converted into Mg+2 ion by loss of 2 electrons, its electronic configuration is 2 and 8. 2 and 8. That means they get nearest noble gas configuration Ne. So here by the loss of 2 electrons, it is converted into Mg+2 ions and gets noble gas configuration. And here bonded atom, another one is oxygen. So the oxygen is oxygen atomic number 8 and their electronic configuration 1s2, 2s2, 2p4. That means 2, 6. So here oxygen is taking 2 electrons from magnesium, and that symbol is 2 electrons. And whenever it is takes 2 electrons, it converted into O-2. That is electrons taking place, and their electronic configuration is 2, 8. Then it is also possess nearest noble gas configuration. So in this formation, what happened? Oxygen is taking 2 electrons. That means taking off electrons indicates reduction. So what is it here? Redox process means what? Reduction, and oxidation process is called redox process. So in this process, magnesium and oxygen both are undergoes oxidation and reduction. Not both. Magnesium undergoes oxidation, oxygen undergoes reduction. So here the formed ions, that is what? Magnesium +2 ion and oxygen -2 ion. So when oppositely charged pieces are coming very close together and they can fuse and they form one compound, that is MgO, magnesium oxide, and during this formation of ionic compound, it released a certain amount of energy. That energy is called lattice energy. So lattice energy means what? Some amount of energy is released when 1 mole of ionic compound is formed. So that is called lattice energy. We will discuss about lattice energy in the next one. So this is one example, formation of MgO. So I am asking one question. What is the electrovalency? What is the electrovalency of magnesium and oxygen in a MgO compound? So what is the electrovalency? In that one, once observed, how many electrons transferred? Magnesium only 2 electrons transferred. Oxygen also transferred 2 electrons. That is what? Magnesium lost the 2 electrons oxygen gains the 2 electrons. So number of electrons transferred is 2. So the electrovalency of magnesium is 2 and oxygen also 2. Oxygen also 2. This is about formation of MgO. Okay.